Okay, welcome to the second video about working with geographical data. In this case, geojson and stuff. And in previous video, we saw um, how we merge smaller areas into the bigger area. For example, merge municipalities into state and only draw the border of the state and things like that, using libraries like TopoJSON client, turf.js. And now we are going to import the resulting geojson, of those states, for example, to MongoDB, because MongoDB has this feature called geospatial queries. So yeah, of course it's very useful for certain scenarios, right? Turns out that it's not as straightforward as I thought. I thought it was just gonna be, well, it's just a Mongo insert, but that was not the case. I got an error first because uh, in order to enable those geospatial queries, you have to uh, create an index in that collection. This type of index, the 2D sphere index. I don't know exactly how it works, but it performs validation on the you know on the GeoJSON's data in the document when we try to insert that document into the database. So if if the geometries are not valid, then the insert would fail. So let's just see how it fails, right? Remember, we have the input. Just a recap of the from the previous video. Where's developers Google? Okay, so our inputs are, where am I? There you go. Where? Okay. This is an example of input. This is from the state of Jalisco in Mexico. It's a big file, 24 megabytes, because it has feature for every single voting section in the state. So yeah, that's what the next script is gonna do, is to merge all those features into one, the state. But as we have found out, working with GeoJSON, doing those union operation is extremely slow, and probably it's not gonna finish. So had to do some intermediate steps, that is converting those GeoJSONs to TopoJSON, because TopoJSON is like a compressed structure, and it performs certain calculations more efficiently compared to using GeoJSON's data, right? So first, we have to convert the GeoJSON to TopoJSON using this script. Well, this is my script actually. So my script only calls this tool provided by TopoJSON server. That's a Node.js module. You can look it up in npm and then call this script, provide the input, and we'll and that's the output. Actually, I've run that script. So we have the TopoJSON here. Yeah, so we can actually draw that topo.json using map shaper. I'm not sure if it's gonna crash because of the size. You see, the size of topo.json is half the size of geojson in this case. So I hope it is gonna work. Let me just drag it here, import. Oh yeah, it worked just fine. Yeah, it's the same. It renders every single electoral section. So this is the structure that we're going to work with, that we're going to merge. So I have another script called estado border topo.json script. Okay. Yeah, so it's gonna execute this JavaScript code that I wrote. Performs server operation, read the topo.json, invoke this merge function from the topo.json client library. Yeah. So let's just run the script. The script is supposed to write the output in this folder borders. Currently it's empty, so let's just run it. Topo.json blah. Okay. 13. There are like 32 states in Mexico. So let's just wait a little while. 25, 27, 29, 30, done. Okay. Now, what's next? Now that we get those topo.json, I need to convert it to, I need to, convert it back to geojson, this file. It's one of those files. Why? Because currently, it would be nice if Mongo support topo.json, but that's not the case for this moment. It's still an open ticket. I think they're working on it. MongoDB topo.json support. Yeah, you can see. So somebody requested that feature. I don't know if they're working on that. It's been 3 years now. Yeah, anyway, so we cannot use the topo.json for now. That's why we need to convert these files back to geojson. For that, I have another script called cat bulk topo to geo. Yeah, cat topo to geo. Hi, sorry. Boom. I'm using this script provided by another Node.js modules called topo.json client. And this is the input, the topo.json that we just produced, and this would be the output. And the output would be stored in this folder. It's currently empty, so let's just run the script. Bulk topo to geo. All right. It's quick. It's just JSON transformation. Well, not really just transformation. It will, because it will have to expand those arcs into points in the GeoJSON structures. So we got the GeoJSON. Can we just read each one of those files and simply do an insert to Mongo? And well, the answer is not really. We need to transform it because um, first, how is this GeoJSON structure, right? So let's have a look into it. For example, uh, sorry, what? Oh, no, border. There you go. So it's features dot geometry dot coordinates like this, while Mongo requires the structure to be in slightly different way. Yeah. Yeah, for example, if you have a data of let's say of a restaurant, you will have to structure it this way. For example, this is name of the restaurant, Resto X, and then you'll have to have a field. You can name it location, for example, and this location will have to have type, and type should be any of this value. Okay, it's in the same way. Point, line string, polygon, multi-point, multi-line string, multi-polygon, and geometry collection. Either of them. So, for example, geometry, and yeah, and the next would be the coordinates. So you will have to have this this structure. Oh, sorry, geometry collection would be geometries. So it doesn't map perfectly to this GeoJSON contents. Yeah, it's not really that different. You just have to move around things. So I want to have like geometry collection, so I have to build geometry object out of these coordinates or something like that. I don't quite remember. Let me just see my code. Yeah, I just move around the properties, the collection, and map the features into map this array of features into array of geometries. So that's all. And then I want to have it in this collection. Sorry, where is it? My Mongo here in this collection, the status. Okay, so let's just run the script and we'll see the problem here then, which leads me to conclusion that working with this GIS data is quite laborious maybe, and probably it will have to involve some manual work. Okay, what's my script? Insert node. What was the comment? Guess I need remember. Oh, there you go. Okay, there. Boom. What? Insert estado. Oh, I'm in the wrong folder. There you go. In fact, it failed on the first one. Aguas Calientes. So it doesn't insert not even one single, so it stopped there. Okay, so what is the error here? Duplicate pieces in array, index this and this, say somewhere here. Well, at first I tried doing it programmatically. Well, if it's duplicate vertex, then I can just iterate through the elements of the array and just remove the duplicates, or probably use some library like Lodash to do that. I tried it, but it doesn't really help. It doesn't. Yeah, I managed to get rid of this issue, but then there comes a more difficult issue. Give me a second. What was the more difficult issue? Maybe we should go back to my code where I do the cleaning up, the deduplication. Okay, I can maybe dedup. Okay, cool. Okay, let's just, yeah, this is my dedup code. So I scan the array, have it in a map for its coordinate point that we've seen before. So yeah, we can avoid duplicate. So let's see if it helps. It doesn't, but we'll just do it so for us to see. All right. See, there's another type of error. Edge blah cross. So it's like they're like lines. Of course, if it's a perfect polygon, you won't expect to see line crossing, right? So that's a problem. Now the question is how to get rid of those problems. I've googled around, and it's not really a trivial thing. That's why they don't have that in library like this. For example, something like remove line, or let's say intersect. Well, yeah, there's a, but it's not for that. You see, it only detects if there's line intersection. Well, you can use that. You can go through each lines in this long array and try to find intersection and remove that somehow. But it's too much work actually. Well, this one is to create intersection like this one. So I don't find an easy way to do that. Not neither I find it in the GeoJson client. What? Remind me later. So there's no function that I can use here. So long story short, I came to conclusion. Yeah, we need to do some manual work. Well, before we proceed, maybe it's a good idea to see that geojson in order to understand like visually what the problem is. So let's go to this file, borders geojson, and we're talking about Aguascalientes, which is this one. Let's open it in map shaper. Where is map shaper? I just close it. There you go. You see, probably the one causing problem in this case, it's simple. It's just one line like this one. So of course, even for this, I couldn't find like programmatic way to remove this. So well, let's do it manually. Somebody ran into exactly the same issues as mine, so there how I came across this tool called QGIS. Which is free. It's really good. So I have my QGIS open. Let's just create a new project. Import a layer. Just drag and drop our geojson here. Okay. So what we can do is doing some vertex operation. Then here. Edit vertex operation. Delete. Okay. This green cross, it indicates a duplicate vertex. We can manually delete it, but I think there's a better way. Okay, at least like visually I can see any more lines like that. Maybe it's resolved now, but there is a tool here, processing toolbox. You can find something like remove duplicate, right? Duplicate, delete, remove duplicate. Okay, let's just run this. I'm not sure if I have to run this before running another script called fix geometries. There's another function called fix geometry. So, but let's just do it from the basic, just to reenact my path to discovery. So let's just start with the remove duplicate, delete, remove duplicate vertex. Double click here. Oh my god, it's so slow. I mean my laptop. Blah 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 blah. Input layer this one, and we will create a new layer. Run. Boom. It says and it's not clear from the log if it actually removed those duplicate vertices, if any. But anyway, let's just assume it's been clean. So, well, I thought at first, well, let's just try to use it to import to Mongo, right? So we need to save it back, this layer back to geojson. Save as, let's just save this here, geojson. I'll create a new folder, borders valid. Name border secciones 01.geojson. Save. Okay, cool. Now let's rerun the script. I don't know why is it so slow. Rerun the script, but first I need to change the path. Borders valid. Borders valid. Okay. still is it, yeah, it's still the same error. Sorry, I had to continue this video at some later point, so this is a like the second recording. And so where were we? We tried to insert these documents, the geojsons that we extracted from the input JSON into MongoDB, but we got an error. Mongo rejected with message like duplicate vertices and what else? Crossing edges. So that was because the geometry in that file, in those files, are invalid according to some rules, and yeah, maybe some standard geometric rules. And Mongo performs that validation because in that table, in this table estados, we have created an index of type 2D sphere. Okay, we need to have this index in order to be able to perform geospatial queries. So yeah, so it's important that we solve this issue. We need to clean up these GeoJSON files. And the tool that we can use is this thing, QGIS, which is free, and the conclusion is it involves some manual tests. So I tried to find completely programmatic ways to get this job done, but it's just maybe it's just too difficult, or maybe even impossible. I don't know. So for now, I stick with this conclusion. Some manual works are needed. So let's do the cleaning up. Let's open this thing. Okay, this is actually it seems quite clean. So what was the problem? I'm not sure, but things like let's say before we try to do some more advanced, I found that this combination of tasks get the job done for most of these files. Some files will require more, more work, but let's start with the basics. First, I apply fixed geometries, and it will create a new layer, and then over that layer I apply another operation called remove duplicate geometries, run, close. I think you can automate that. This thing allows some Python scripting. And then remove duplicate vertices, run, and yeah, you can try to save that. Save as, and put here in a folder name geojson's borders valid. Yeah, borders valid. Well, so far I've already got this done for 15 states. No, I haven't been able to finish the entire 32 states. Yeah, takes time. Okay, save it, and then try rerunning the script to insert to Mongo, right? On top of these three operations, in some cases, so if you fail even after you try to insert this clean version, then you have to go back and then apply an additional operation. Some can use some one of these functions in the toolbox, but some of them will require manual work, like this one. So when I encounter a message, an error that says like edge crossing, something like that, well, actually, I don't know exactly what that means. Yeah, yeah, it's clear that there's a path that crosses, but you can go to the file, geojson, and analyze yourself and remove those vertices somehow. But it's just the file is too big. You wouldn't be able to edit it. So that's why this tool comes in handy, right? You can see here, this looks like crossing lines, right? So you just, because you're only interested in the border, just delete these lines and probably you're done, probably not. So you need to check a little deeper, more details. I usually walk around this border, zoom in, just it just takes some patience actually. Okay, try to find some other lines like that. Yeah, okay, let's say I've cleaned it up, remove all those lines, and then okay, repeat the operations to insert to MongoDB. Okay, let's see for the last one. Let's see something more complex. Which one? Which state is more complex? Let's see. I think 13. Jalisco. Okay, Jalisco 14. That's the state where I'm living now. Jalisco. Okay, it's quite. It looks quite clean, except this one. Well, that's easy. You can just remove this vertices. Oops. Yeah, it's a bit slow here on my laptop. It takes 10 seconds from now, I guess, or not. Oh my god. Okay, yeah. Okay, anyway, I won't do that again. Okay, you delete that as easy as that. The same thing for, but here I found that you can't remove these lines for some reason, probably because they're shared. So actually it's not one single polygon. That's what I remember from this case. So it's two polygon, and if you remove these lines, this polygon will be removed. You don't want that, so you need to do some tricks to merge these two polygons, right? So that's basically it. Without going too deep on this, because actually I don't know what is the shortest set of operation, the minimum set of operation, but I've tried things like dissolve. I have also tried what else? Convert to lines, polygon to line, to lines, polygon to lines, and then explode lines. So by exploding lines, you would be able to remove edges that it will explode these lines into set of edges of two vertices, so that you can delete them individually, and then you have to merge them back, and then finally construct a polygon back from that fixed lines. That combination of operation, once you get that done, you will have these documents in your table, right? uh, have I extracted the properties from the geojson and inserted here, that to help some basic queries by properties. And the geographical data is here in this field. As the documentation of Mongo said, it has to have this type, which can be either a point, lines, polygon, multi-polygon, or a geometry collection. And depends on the type, the next field can be either coordinates or geometries. Okay, so You have to read that GeoJSON, perform some simple transformation like this one, and then insert that to this table. Once you have that, then you're ready to exploit that information. For example, notes. Okay, this is just an example. So I have, just for the sake of discussion, I have another table, interviews. This stores the interviews carried out by our worker on the streets, and then yeah, interview has obviously it's just these documents is just like simulated, right? I don't even have the answers for the questionnaire here, but we have the coordinates, right? Because the interview, the agent has the mobile application, and it records the coordinates where the interview was conducted, right? Latitude, longitude, and here we want to find out in which state these interviews were carried out. So I got these points from this 20 103 20 103 32 116 32 116, yeah, this one. So these two interviews, I've checked that in Google Map. Wait. How is that? Oh, this. So to perform this test, I picked the coordinates from here. You can see in the URL the coordinates, and just copy that into my fake data, and then perform this query. This should give me one result, that is state of Jalisco. Oh no, wait a second. Oh, this one is in Tijuana. This one is in Baja California, in the city Tijuana, and this one is in the city Guadalajara, Jalisco. So yeah, that's why I got this result. Okay, so these points, these interviews were conducted in these places. So that's what the query informs us. Another query like this, for example. So for example, I'd like to know, hey, give me all the agents or all the interviews that were carried out in Jalisco. So first we need to find the geometry that that define Jalisco, the state, right? So I this is what we do. We got the record from the estados table, and then we compared it against the location of the interviews, right? So the operation that we use is geowithin. So I'd like to know all the points taken from the interviews that are within the border of Jalisco. So this is what the interview about. So if we run this query, you'll get, okay, so these are the two interviews that were carried out in Jalisco. One is by Agent Smith, the other one is by Agent Sonian. What else? Yeah, so get creative. Lots of things that we can do with map information, and because we're in the survey business, as doing some socio-economic political studies, and many of these teams have a lot to do with location, where people live. You see, people don't really integrate, right? So you can see some pattern. You can see some pattern there. Yep. So we have a table for each level of division: estados, municipios, municipality. Oh yeah, we need another one. Colonias. That's the, I don't know what's the English word for that. Colony, county maybe. Oh no, counties, municipality. I don't know. In Mexico, you have the country, you have the state, you have municipality, and below that you have colonias. And there's also another division, only applies to zona conurbadas, like area that actually have people living within the area. It's called AGEBs, and it's not necessarily yeah, it's a parallel structure. It's not within the colonia. It can span multiple colonias, stuff like that. We have colonias, and for the election we have another division called secciones electorales, electoral section, and then distritos electorales. So yeah, for each one of those division, we have our GeoJSON. Why not having them in one single table? Well, first and foremost, maybe it's an optimization techniques, right? When you're only interested in information at the state level, for example, you don't need to look into the municipality levels. Yeah, so you need to work on the right level of detail. So that's the idea. Um, yep, I think that's all. um, Working with map or geographical information data, it's quite challenging. It's quite laborious. I think it just like working with any data, especially when you have to prepare data, clean up data. That's interesting because the bulk of the work is there. So you need to be resourceful. You need to know the most efficient workflows. You need to know the best tools. Yep. Here in this video, I'm just sharing what I've learned so far working with GeoJSON data. So that's all. See you in another video. Bye.